Well, hi everyone. Thank you so much for having me. I'm really nervous, but I will try to calm over the speech. So my goal today is to tell you about the image optimization techniques we have nowadays in the web ecosystem and how to apply them to the Jamstack ecosystem too. Jamstack is an architecture, and I will explain you later in the introduction what it is in case you don't know it yet, so don't worry about that. If you scan this QR, it's just the slides, just in case I have so much text on it and you need to read, maybe it's better that you have it in your phone. So please check the QR and we can go further. Okay. So in this talk, I will show you an introduction about web performance, about image optimization, and what is Jamstack, just in case you are not aware about this architecture. Then I will show you the optimization techniques we have with solution in the theoretical part and also the practical part that you can use while using an image CDN or image service that I also will explain what it is. And then we will see a small case study I made using a Storyblock, because Storyblock is a headless CMS, but also provides an image service. So you can use it while creating your applications on it. So yeah, before we dive into the topic, I want to introduce myself a little bit, but yeah, see, I already did it. But actually, I'm a developer relation engineer in a Storyblock since 4 months ago. Before that, I was a front-end developer for 7 years, so I already have experience in front-end development, but I'm kind of new at speaking at events, so that's my new role, let's say. And I'm a Nuxt ambassador because I'm in the Vue ecosystem. Sorry about that, because I know that all of you are from React, so I will just skip this part. And I'm a Google developer expert in web technology since 2 years ago because I started creating content in the community. And if you do so, I hope that you can join the program because it's really cool and you can go to events also paid by them. So that's actually really cool. And since 2 weeks ago, actually, I have been named Woman Tech Making Ambassador just to have created the No Me Da La Vida podcast, where we talk with women in tech about different roles in the ecosystem, not only about frontend, because in the beginning we were only talking about frontend because we are frontend, but of course now we interview more people to know more about them. So now, well, let's start with the talk. Basically, today we are creating a lot of content online, and the problem is that we are storing a lot of data in multiple data centers, and companies like Google or Netlify or any hosting provider seek for solutions to optimize every data we are storing, so to make the web faster and lighter, so we can start creating content for all our products and maybe a personal site, but don't make all the data centers have a lot of content that maybe is not doable. So the idea is that web performance comes into the picture because of that, to start creating content without the problem that we have nowadays of storing a lot of data. And it's as important as trendy as having online presence. If you want a website to be online, now the search engines like Google will rank you better if you have a better performance. So let's do that, and let's help the web to be bigger, but also faster. So what is web performance? Well, as Anna explained us yesterday, web performance is just the speed as a website loads. So basically how the user receives your website, how fast it is, and how they perceive that fast. Because maybe if you just measure the performance, it's really good. But if you check as a user the performance, you think that it's not loading that fast because they are making hacky things to make you think that it's faster, at least to the browsers. But the user point out that it's not that fast. So that's why the performance is both of the things, the objective measurement and the perceived user experience. So now let's think, what is the relation between images and web performance? Well, as Web Almanac addressed in this sentence, 96% of pages contain at least one image tag, and 99, almost 100%, at least have one image request, so maybe as a background. Basically, we are adding images to all of our sites, so basically images are the main pain point in web performance, and for that we need to be aware of that and start optimizing our images. So what is image optimization? It's just how a high-quality image needs to go to a process to start sending to the user the optimal image that you can have, with the ideal conditions, the ideal size, the ideal format, everything that you need for that specific viewport or device. And while optimizing images is really important in any website, in Jamstack it's even more paramount because the idea of Jamstack is improve web performance. But if we don't have proper images, our performance will be bad again. So the idea is that we need to combine the image optimization with the Jamstack architecture. And as Web Almanac addressed too, because Web Almanac is always having a lot of quotes about this, the images are the main bottleneck for a good UX in any Jamstack site, because Jamstack is already really fast, but the images are not that much. So what is Jamstack for those of you that maybe don't know? Jamstack is just what we call static sites, but made with dynamic technology. Basically, we are decoupling the web experience layer, the front end, we can call it, and the data and business logic, the back end, improving the flexibility, scalability, performance, and maintainability, because we can decouple completely what is happening on the back end and what we are serving in our servers to the front-end layer that is already pre-built. So each time we deploy something from GitHub, it will be pre-built in the hosting provider, and we as a user, we are just receiving a static page delivered by a CDN. So the idea is that this is the main goal of Jamstack, but the images are already in a server, and they are being called. So we have this problem that the images are not good enough in any Jamstack site in the web nowadays. So now that we know the concepts behind this talk, I want to show you all the optimization techniques we can apply for each problem we will face while working with images, but with a kind of feature, let's say, or ability of the Pokemon world. So what ability can relate to these optimization techniques? The first issue that we will face while working with images is the use of large image files. Basically, a content editor will put something to our site or our CMS, and the image maybe is not properly optimized. But of course, that should not be a part of the content editor works. That should be the developer work, or at least our code should do it. And basically, if you see the Lighthouse error, you can see that avoid enormous network payloads is an error that always appears with JavaScript, but in case you have grown images, it will appear also with huge images, as you can see in this screenshot. So the solution is really simple. We just need to compress and reduce the size of our images. If you think about catching a Pokemon in the wild, you need a catch rate an optimal catch rate to catch them. Well, the idea with the images is if you want the same image to appear the same and look the same, you will need a compression rate, a quality that is similar to the one that you have already. So for doing that, you have two different techniques. You have the lossy compression that eliminates the less critical data and is losing a lot of quality because you are actually removing data, and the lossless compression that not lose that quality, but of course will be larger size file at the end. So when choosing one of them, you need to think, what is the value proposition of my project? I'm actually focusing on images. I'm Unsplash or Instagram. I need to deliver a really looking good image. Then I will use lossless compression. But in case the performance matters most, I need to deliver a really high quality content and really fast. Maybe the image is not that important, so it's better that you use lossy compression. And to apply that to your developer workflow, you have these kind of tools like Calibro app and ImageBot that if you click on it, in the slides are links to the actual project. And they are GitHub actions that you can add to your workflows, basically in GitHub. And they can just create pull requests with the images, compress already for you. But of course, no one is storing the images inside GitHub or in the repo of the developer. We are storing images in the cloud. So for that, nowadays, we have the Image CDN or the Image Service, also called. So basically, it's a combination of a transformation API that is changing the images on the fly. You are just adding parameters to the URL, and the image that is delivered to you has these parameters on it, like the size, the compression, the format that you want to transform. And also a CDN network that basically is catching the images for you and delivering really fast to the user. And in this case, in this talk, we will use the Storyblock Image Service that basically is the same as we have in Cloudinary or ImageKit, any one that we can use. But the idea behind this is that if you're using a Storyblock as a headless CMS, each time you push or upload an image, you just need to add to the URL /m/, and the image service will be applied already. So each time that you are doing that, you are having that image compressed already with an 80% of compression rate. And if you want to change the compression rate, you need to use the filter quality with a number between 0 and 100. And in case you want to check out all the parameters that the image service has, of course, we have a guide, so you can check it out. And well, when you have your image compressed, the second thing that you will face is the use of older image formats. Because of course, nowadays we are aware about the next-gen formats like WebP or AVIF, but we are still using JPEG and PNG for all the sites where we're loading images. And that is kind of weird because it's always we're saying the compression and delivering larger size files when we can have very proper images just using WebP. So the idea is that the solution is that simple as using the next generation formats and reducing the file size so we can provide a better UX and actually a fast download of our site and consume less bandwidth. And the idea is that if you think about Muse transformability, Muse will transform into another Pokemon and get all the benefit from it. So the same we can think about our image. If we want to transform it to WebP, it will reduce the file size by 26% or more. It depends on the one that you are compressing. And it will be uniform across all the browsers because, for example, AVIF, as you can see, is better in compressing, but it's not compatible in everything yet. So we need to wait. But when we wait, we will have a really proper format with AVIF. So I think it's the future. And in StereoBlock, as the auto formatting is working just by adding a /m/ with the image service, we already have WebP if the browser supports it. If the browser doesn't support it, what it will do is just provide the original image, PNG or JPEG, but also compressed, of course. And if we want to change the format specifically, we can use the filters format, and that will provide the format that we are specifying there. Well, when we have already everything in place, we will have another problem that is kind of common and everyone knows about it, but I don't know, we are still not adding it to our image tag, and it's the unit-specified dimensions. If we don't add width and height to our image tag, the problem is that the browser doesn't reserve a curly space. We don't have a placeholder box, so the layout will change while the images are loaded. So I will just play this small video with the demo. Let me see if I can find the mouse. Here. So you can see if I don't add anything, this will happen. If I want to click the Discover button, I will not be able to do so. And maybe I will click the Chrome button and I will buy something. So the idea is that we need to specify width and height. That's the only solution we will have. And OK, so we just need to add the width and height to our image tag, but not only to our image tag, also to the source tags. And why I'm telling you this? Because if you think about responsive images and you think about different images per device using the picture tag, usually people didn't add width and height to source tags, and then the image aspect ratio will be covering it. And that's not what we want. The idea is that you can think about adding width and height as the Dynamax ability on the Pokemon world. Basically, they are changing the world around them, and in this case, the image is changing the page around them. So each time they want to be bigger, the placeholder will specify that, and at the very beginning, we will not see anything, but at least the placeholder is already there. And at first glance, we can think that maybe it's a really easy job for a developer just to add width and height. Well, but this is because the browsers do a tedious job in the background, trying to think how to detect the aspect ratio per scenario. And in this case, I point you to two scenarios that we will face. As Rachel said in the previous talk, the responsive design is stretching or making wider the images. And this is because the browser can calculate the aspect ratio if you set the width and the height. But if you don't have it, the aspect ratio initially will be grown and will be height to 0 because they don't know actually the height of the image. So you just need to specify it and everything will work nicely. And the second scenario that you will have is the different images, as I told you. So basically, if you add more source in this picture that are not the same aspect ratio to the original image, then they will expect to have the original image size. And that's not the correct way. So if you specify different width and heights, it will take different aspect ratio per device too. So now that we see how to optimize our images with the basic stuff that everyone will face, let's think about images that are really different from device to other device. So this first problem, the not optimized for the device, will be related to pixel density. So when we are using, for example, Apple devices, Of course, we have more pixel density than any other devices because they have really huge resolution. So this is a problem when we just actually create one image per device, and we didn't think about the images, how they will look in a device made by Apple. So in this case, the problem that we will face is that we have low resolution in our images in this kind of devices because we need wider ones. So the solution is use responsive images. We have this kind of solution to the browser. So this is allowing the browser to choose an appropriate resolution for that specific display density. And using the image tag with the source set attribute, we can just specify the density descriptors, the 1x, 2x, 3x that you can see here, that are the basic ones. And you can, in the source set, specify the image related to that x that you can see there. But basically, they are wider images or smaller images. That's it. And in the source, you will have a fallback. In case the source set is not read or any of the conditions are met, then that image should be able to be rendered in any device. So it should be always the bigger one. And in the Pokemon world, I can relate this to the heavy metal ability that makes you wider in just playing the ability. So now that we found this about the pixel density, there is other problems that we will face while working with different devices. Of course, if we change an image from desktop to mobile and we deliver the same image, we will have in mobile 4 times data, so we need to make it smaller for sure. But the same will happen if we think, no, let's deliver just an image, a mobile image, and then in desktop will be better. No, that will not happen, actually. So if we want to resolve this, we just need to think about responsive images with descriptors instead of density descriptors. The difference between them is that for this time in the source set, you will specify the width of the image in the viewport, not the screen size, the image, how it will be wider. And then you can specify which image will apply to this with descriptors. And once you have that, of course, you can play with sizes, but it's optional. The idea of sizes is a list of media queries indicating the image's width when displayed, and not the screen size. So you can play with them, but basically, if you have source and source set, it's already OK. You don't need to do that. And you can think of it as the evolution of Pokemon when they only change size and not the form of the actual Pokemon. And of course, you will think, of course, if I do that, I need to do all this image manually. Of course not. We have the image service, and it's already doing it for you. If you just need to specify the width and height in the URL as parameters, and if you specify to 0, the opposite to the one that you want to have the aspect relation, so for example, proportional to height will be 0x and then the height, then you can have a proportion with the same aspect ratio of that image, maybe wider, maybe smaller. So you can just play with it, and it will be always catch that request too. Then the last thing we will face while working with responsive images is the not designed for the device. Basically, we have a lot of tests in one image, and when we go to phone, everything is cropped. That doesn't have any sense. So for that, we just need to use the responsive image this time, but with the art direction technique. The art direction technique is just providing a specially designed image per device. So we use the picture tag, and inside them, we just provide all the sources for the different devices. In this case, the sources media, the first one, will be the mobile one, and then the tablet, and then the desktop with different images, not only different sizes of the same image. So it's kind of the evolution of the Pokemon when they change the aspect, but they are the same image, but saying different to the user. And if you combine this art direction with the different resolutions, basically the pencil density of the screens, as you can see on the source set examples, you can have the images that you have per device also ready for the device of Android or iOS or whatever that you are representing your image. So that is the cool thing about the art direction. And then one of the issues that happens the most is that we always load the images before the critical resources, or at least most of the projects do. But of course, we are aware of it. The idea is that if we don't specify the priority of our image, which one is above the fold and which one is below the fold, we are causing poor performance and increasing the time to interactive. So that's not cool because the user needs to wait a lot for things that are not in the screen they are seeing. So the solution is really simple. Just use the loading property. And as the same as Snorlax will do when you play the float and play music to him, the images will awake when you scroll the page. So you will just using the lazy loading native feature that we have in the browser, we can already have that in place. And of course, don't use it in the images above the fold. If you have an image in the very top of your page, don't use lazy loading. Otherwise, we'll wait for something that should be there already. In case that you do that, use the eager option instead. So it's the auto one by default, basically. But if you use it just in case you forget it, it's better to use eager than put lazy to the ones above. And then, as Anna told us yesterday in the web performance talk, if you use the Hint Preconnect with the image service, you will have your images delivered faster than if you don't add it. So just add your image service domain there. And the last issue we will face is the no-catch image, but of course, we will not have that problem because we are using an Image Service CDN, so it's already doing it for us. But you will have this problem if you don't have an image service, so just, yeah, the solution is store the heavily accessed images, the images that are most appearing in the screen of the user, in the end user, because they already have it in the system, so they can have it just from the browser. You don't need to actually catch them in the server. But in case you want to catch everything in the server, you have, of course, the Image CDN to do that. In the case of Storylog, just adding /m/, you are actually already catching everything that is requested, and also all the transformation you are making to the URL are also cached. So think about it like the copycat move of Pokemon that will make the user to use the last move that they use. Well, in this case, it will be the last image that they've seen in your screens. And now that you know all the techniques, let's try to apply them really quick in our project. Our project is using Nuxt and Vue. For that, I skipped the code part. But we have also Storylog as a headless CMS and image service. What I did is just create a component in my headless CMS that the content editors will use with presets. What I did is create the first one, that is the design image component. The design image component has just the images we need per device, the different ones, the ones that are the art direction technique. And the image component, the second one, it will have all the properties and attributes we just saw in the slides. And when we define them, we will make presets so the actual content editor can choose one of them and then provide, for example, if we have a banner, it will have a width, a height, and also a responsive sizes that they can already use by clicking on the preset instead of creating the component from scratch. So once we have that, I created this demo that you can find all the links in the slides. Basically, it's a duplicable space on Storylog, so you can have already my project, a GitHub repository with the code made in Nuxt and Vue 3, and the live demo site so you can play with it and check what is happening when you just make wider the screen or not. And actually, the funny thing is that using the Lighthouse report with a Jamstack project just built in a static mode, you can see that it's already 72 with just 4 images, and images that are above the fold, actually. So the idea is that just using these techniques, you will have everything ready since the beginning. So just create a component that you can reuse, and that will be better for your project than not using images without optimizing them, for sure. And of course, this talk was just a summary of the article I write in a Massive magazine about image optimization on Jamstack sites, where you can see also how I created the project in detail, and you can replicate it, basically. But you can extrapolate everything to any technology, for sure. And that was it. Thank you so much. And I hope you liked it.